just want to give you an overview of some of this plotting stuff, plotting with straight lines. There's a whole bunch of online plotters. I'm using foodplot.com. You can Google free online plotters, and there's, I don't know, thousands out there. I'm just using foodplot.com, but any of them will do. And it's got a graph in there at the moment saying y equals x squared. Let's just delete that for a second. And what I'm going to type in is y equals 2x. There we go. First thing you notice about that is it's a straight line. And if we have a look at this, what this basically says here, y equals 2x, it says for whatever x is, double it, that'll equal y. So if x is 1, y is 2, if x is 3, y is 6, and so forth. Well, is that what this graph's telling us here? If I just grab this and move this down here. So here is x is 1. If I go up, y is 2, which confirms what this says over here. If x is 2, y is 4. Because 2 times 2 is 4, and if we move this down a little bit here and have a look, if x equals 3, y is 6, and that works the other way as well. So in other words, if x is minus 1, 2 times minus 1 is going to be minus 2. If x is minus 2, 2 times minus 2 is minus 4. So that all seems to check out. What about if I make this, actually we'll do it this way. We'll say 2x. What about if I add 1 to it? So whatever x is, we're going to double it, and then we're going to add 1. So let's have a look at this graph here. So let's say 2 times 1 is 2. That's fine. If we added 1 to it, that means that point should be probably that point there. And if we had 2 times 2 is 4, plus 1 is 5, so instead of that going there, it should go there. And if let's have a look at the minus numbers here. If I did 2 times minus 1 is minus 2, add 1 should take the pointer back there. So that would suggest if I did 2x plus 1, I get another line, straight line, but it would just run slightly above it. So if I do 2x plus 1, that's exactly what we get. And in fact, let me stick both of them in. Let me just add another one down here and do 2x. There's your original line. So change the colours of this so you can see what's going on. Or I don't make it red, something like that. Is that red? That looks like sort of reddish. There we are. I've got here, this line here is 2x, and this line here is 2x plus 1. What about if I did, I don't know, 2x minus 2, for instance? So if I add another function here, add a function, and let me just delete that. If I put 2x minus 2 in here, 2x minus 2 gives us this line. So this is basically saying, let's go, let's do this one here. So 2 times 2 is 4, which you bring up there, but then you're taking 2 off it, so it brings you down to that point there. So it's giving you still all straight lines, and it's either shifting them up by plus 1, plus 2, plus 3, or whatever you put in there, or moving it down, minus 1, minus 2, minus 3 here. But the interesting thing is, all 3 lines are parallel. All 3 lines have exactly the same slope. So the only thing that's sort of constant in all these things here is that 2 there, that 2 there, and that 2 there. And that says all of those have a slope of 2. If you go 1 along, you go 2 up, 1 along, 2 up. Well, is that the case? Let's just have a look here. If I take this one here, if I go 1 along, I'm going 2 up. 1 along, 2 up. And there's the same for, if I look at this line here, there we are, start there. 1 along, 2 up, 1 along, 2 up. Exactly the same. So the slope of those is all slope of 2. They call it gradient. Gradient is the posh word for slope, how steep it is. Gradient of 2. Well, what if I change those to 3x? 3x. Cursor's just disappeared. 3x. 3x. Well, the first thing you notice is that all 3 of them still parallel, and they've all now got a slope of 3. So this first number here, whatever you're multiplying 3 by, is going to be the slope, and that's what we've got here. If I take this one here, if I go 1 along, I go 1, 2, 3 up. If I take the red line here, 1 along, that's going to be 1, 2, 3 up for the red line. Let's just change the colours of these things so you can see, do it something like that. How do I change the colour? Something like that. There we are. No, I thought it was going to change the colour for me. Oh well. So that's basically how you control the 3. And what about if I put in here half x, 0.5x, 0.5x, 5x. Notice now that they've all got the same slope again. This time the slope is a half, so this is 1 along, halfway up. 1 along, halfway up. The same up here. See, that is 1 along, halfway up. So that slope there, that determines that number at the front that you multiply next. That determines what the slope is. What if I make that negative? What if I made that minus 2? Minus 2. Minus 2. They're all still parallel because they've all got the same number at the front here, but it's minus 2, so that's a negative slope. So if I look at, this red one here, let's take it from that point there. 1 along, 2 down, 1 along, 2 down, 1 along, 2 down. Now they're all the same idea. If I take the green one here, 1 along, 2 down, 1 along, 2 down. So that's basically how that number at the front works. That number says the slope of the line. Go on to foodplot.com, have a play, see what you think, and then we're going to go to talk about intercept.